Hi, in this video, we'll be looking at how to find the adjoint of a matrix. In subsequent videos, we've talked about the types of matrices that we have. So one of those types of matrices we looked at the transpose matrix. We said we have a matrix A, and then if we want to find the transpose of matrix A, we thereby interchange the rows and the column. Also, in subsequent videos, we looked at how to find the cofactors of a matrix, where we find the minus of each of these elements and then multiply it with the place sign and then generates a new matrix, hence the cofactor of said matrix. For the sake of this video, we'll be looking at how to find the adjoint of a matrix. Now you should know also that before you can find the adjoint of a matrix, the matrix must be a square matrix. If the matrix is not a square matrix, then definitely you can't find the adjoint of the matrix. So if it's a square matrix, then you should be familiar with finding the cofactors of the matrix. And after finding the cofactors of the matrix, you transpose the cofactors of that matrix, then you find the adjoint of said matrix. So what are we saying? So let's say we have matrix A. A is a matrix. Then we are saying that you find the cofactors of matrix A. So if you can find the cofactor of matrix A, then transpose. So the cofactors of matrix A that's been transposed would be equal to the adjoint of matrix A. So you can see where we're going. So first of all, we start by finding the cofactors of A, which was what we did in the previous video, and then we transpose the matrix or the cofactor, the cofactored matrix, if there's any statement or word like that, and then we successfully found the adjoint of the matrix. So before wasting or without wasting much time, let's quickly look at an example. So for the sake of this video, we're looking at how to find the adjoint of both a 2 by 2 matrix and a 3 by 3 matrix. Okay, so for A, let's say we have matrix A should be given as 2, 3, 4, and -2, and then we have to find the adjoint of A, of matrix A. So first of all, we said we want to find the cofactors of this matrix. So cofactor of matrix A. So if we're using our shortcuts, we swap this, we swap this -2 and then 2, swap this also, but this time around negates the swapping, so 3 and -4. So this is the cofactor of matrix A. So let's confirm, so just in case it's quite wrong. Okay, so cofactor, so just to confirm what we've done is accurate, but this is the long process. Just in case you've not seen the previous video, you don't know why this is true. And note, this only works for a 2 by 2 matrix. It doesn't work for a 3 by 3 matrix. For 3 by 3 matrix, you have to go through the long process. Okay, so for this, remember we said for a 2 by 2 matrix, it has a place sign, plus, minus, minus, plus. Okay, so let's say this is the original matrix itself. So the minor of 2 is -2, because after you strike out the first row and the first column, the only number that is free is -2, but it has a place value of addition. So plus 1 times -2 will still give us -2, which is what we have here. Okay, now the minor of 3 will be 4, but to have a negative sign, so that's -4. Okay, the minor of 4 after striking out 2, 4, and then 4 -2 will be 3, which will have a negative value also. And lastly, the minor of -2 will be 2, which will have a positive value. So you can see that this is the same thing. So I can just strike out 1, so we have space to quickly do the rest. Okay, now it's time for us to transpose our matrix, because we already said if we're looking for the adjoint of A, then first of all we find the cofactor of A and transpose the cofactor of A we've gotten. That will be the adjoint of A. Okay, so transposing this, we have, so when we're transposing, so cofactor of A transpose. So remember, so we interchange the rows and then we make them the column. So -2, -4, and then this will be -3 and 2. So this is the what's it called? This is the transpose of my matrix. So I say transpose. This is the adjoint of my matrix, rather. So this should be given as ADJ of A. Of course, there's a shortcut. From this first place to this last place. So what's the shortcut? We can just start by by swapping this diagonal. So swap the diagonal and then negate swap the leading diagonal, swap them, and then negate the what's it called? Negate the backward diagonal. So what do I mean? So swapping this, I have -2. Here I have 2. So negating this one, I have so you leave this one constant. So not just listen. So remember for cofactor, we were swapping, but this time around we don't want to swap. We want to leave it constant. We want to negate them. So this becomes -4 and -3. So you can see we've gotten the adjoint of A. So our final answer here. Okay, so let's just do one more example before we look at how to find the cofactor of a 3 by 3 matrix. Okay. For a 3 by 3 of the next example. So here let's say we have here we have 2 0 5 6. Okay, all right, so we want to find adjoint of A. Let's say I'm giving this to be matrix A. Okay, so using the shortcuts, the short method, we already said would just swap the leading diagonal. So this becomes 6 2 and leave this one constant, so but negate it, so -5 and then 0, because 0 has no negation. So this will be our adjoint, but let's go through the long process and see whether we arrive at the same answer. Okay, so to arrive at the same answer, so for need to find the cofactors of A. So this time around we'll be using the long process. We don't want to use any shortcuts in between. So plus minus minus plus. So cofactor of A will be equal to, so strike out this, I'm left with 6. 6 has a positive value. Okay, that's perfect. Now strike out this, I'm left with 5. So this one has a negative value. So this is -5. Strike out this, I'm left with 0. So this is 0. Of course, 0 has a negative number, but then 0 has this thing. So it's neither negative nor positive. Okay, so what's the last one? 6. Strike out this, I'm left with 2, so which is a positive value. And this is what we have. Then find the transpose of this matrix. So transposing the cofactor, transposing this. So we have, so if I transpose this, and swap it, interchanging the rows and columns. So this is 6, -5. And then this is 0, this is 2. So this is what I have. So you can see the shortcuts 6 0 -5 2, and then the long method 6 0 -5 and 2. So same answer. So this is how we find the adjoint of a 2 by 2 matrix. So what if we want to find the adjoint of a 3 by 3 matrix? How do we go about that? So again, let's write our matrix. So let's say we're given matrix C to be equal to, so 1 0 5 2 1 6 3 4 0. All right, so we want to find the adjoint of this matrix. So find adjoint ADJ of matrix C. Okay, so first thing first, we want to find the cofactor of matrix C. So unlike the 2 by 2 matrix, this has no shortcut. So you want to write your place sign. So plus minus plus. Okay, minus plus minus. Okay, plus minus plus. Okay, so you can just try to know that the leading diagonal and then the backward diagonals are always positive, while the rest becomes negative. Okay, so now writing the cofactors of matrix C. So let's just denote that properly. So cofactors of C will be equal to, so let me draw my matrix with brackets. Okay, so positive 1. So I'm striking out the first row, striking out the first column. I'm left with 1 6 4 0. So 1 times 0, that's 0. 0 minus 6 times 4. 6 times 4 is 24. So that's 0 minus 24 is minus 24 times positive 1. That's still negative 24. So I have negative 24. Yeah. We move on to the next one. Strike out this. I'm left with 2 6 3 and 0. So 2 times 0, that's 0 again. And then 3 times 6, 18. 0 minus 18 is minus 18, but multiplied by -1, so that's 18, just 18. Okay, now moving on to the third one. So strike out this, I'm left with 2 1 3 and 4. 2 times 4 is 8. 3 times 1 is 6. And 3 times 1 is 3 rather. So 2 times 4 8. 3 times 1 3. So 8 minus 3 is 5. So and then 5 times positive 1, so of course that's still positive 5. Then moving on to the second row. So strike out this. So I'm left with 0 5 4 and 0. So 0 times 0 is 0. 4 times 5 20. 0 minus 20 minus 20, and this negative, of course, that's plus 20. So write positive 20 here. Moving on to the next number. So for this one, strike out this, strike out this. Okay, so I'm left with 1, 5, 3, and 0. So 1 times 0, 0. 0 minus 15. So here I have negative 15. Okay, for 6, strike out this, strike out this. So I'm left with 1, 0, 3, and 4. So 1 times 4 is 4. 4 minus 0 is 4. So times negative 1, so that's negative 4. Okay, so moving on to the third row. So strike out this, strike out this. I'm left with 0, 5, 1, and 6. So 0 times 6 is 0. 0 minus 5, because 1 times 5 is 5. 0 minus 5 is minus 5 times positive 1, so that's the negative 5. So moving on to the next one, strike out this, strike out the middle column. So I'm left with 1, 6, 5, and 2. So 1 times 6 is 6, 2 times 5, 10. So 2 minus 10, I mean 6 minus 10 rather, that's negative 4. And negative 4 times negative 1, so that's positive 4. So write your 4 here. And lastly, strike out this, strike out this. So 1 times 1, 1, 2 times 0, 0. So 1 minus 0 is 1, and then the sign here is positive also. So definitely this would be 1. So we've written the cofactors of this matrix. Okay, so after completing the cofactor, then we need to transpose this matrix. So cofactor, transposing this matrix. So say to transpose. So when we're transposing, we're simply interchanging the rows with the column. So the first row becomes the first column. So we have minus 24, 18, and 5. So second row becomes the second column. So we have 20, negative 15, and negative 4. And lastly, the third row becomes the third column. So negative 5, 4, and 1. So you can see, so this is how we find the adjoint of a matrix. You find the cofactors first. After finding the cofactors, then you transpose the cofactor that you've gotten, and then that becomes the adjoint of the matrix. So this is all I have for the sake of this video. In the next video, we're going to be looking at the inverse of a matrix, how to find the inverse of a matrix. So if this video has been helpful, if this series has been helpful, so remember we started with talking about the definition of matrices, the order of a matrix, the position of elements of a matrix. We moved on to talking about the types of matrix that we have. I think we talked about we moved on, we talked about the addition and subtraction of matrices. We also talked about the multiplication of matrices. Then we moved on to talking about the determinant of a matrix, how to find the determinant of a matrix. So we looked at how to find the cofactors of a matrix. And lastly, or finally, this video, we're talking about the adjoints of a matrix. So if this series has been helpful, so why not share to your colleagues so that they can benefit from what you've benefited from already, and so we can help each other to achieve the same common goal, to ensure that learning has taken place. All right, so thank you for watching. Bye bye, and